Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, question 5 of the revision. Solve the inequality x plus 1 over x minus 1 is less than 4, where x is an element of OR and x is not equal to 1. Okay, so the theory behind this one, okay, or how you do them. So you multiply each side or across by the bottom squared. Okay, so in other words, I'm going to multiply it by x minus 1 squared by x plus 1 over x minus 1 is less than 4 times x minus 1 to be squared. Okay, so it's kind of like I'm getting a common denominator. It's a bit like the question, I don't know, was a question 2 we did that was a fraction. So we're multiplying it by our common denominator, okay? Now, what's different is that it's not x minus 1 as my common denominator, it's x minus 1 squared. So why? Why? That's the first piece of this that you've got to get your head wrapped around so that you don't forget to do the squared part. The reason for the squared is because it's an inequality. Okay, so if I can chat for a second, if you had a question 2x is less than 4 and I asked you to solve that for x, you would tell me x is less than 2. So x can be any value less than 2. And I would say, great, well done. Now, if I gave you this one, okay, solve this one for x, I'm hoping the first thing you would do is change the signs all the way across. And when you change the signs of in front of the x, you change the direction of the inequality. Okay, and then of course you divide across by 2. Okay, so it's this changing direction of the inequality that's troublesome when you get a question like this. Okay, because if this ends up being a minus value, an overall minus value on the left, then I need to change the direction of the inequality. Whereas if this value ends up being an overall plus value on the left, you don't need to change the direction of the inequality. But of course, x can be any value because it's a real number. Okay, so how do we deal with this? How do we know when to change the sign of the direction of the inequality and when don't we? Well, that's too hard. So what we do is we take advantage of the fact that when you square something, you always make it a plus. Okay, so of course, if this is always going to be a plus, then I never have to change the sign or the direction of the inequality. Okay, so just to repeat, when you square something, you make it a plus. So by doing that, I make this overall side be a plus, which means I never have to worry about the direction of the inequality. Okay, so that's why when it's inequalities and you're solving them, you have to multiply across by the bottom left. Okay, so then like any other fraction, the bottom will cancel with one of them on the top so that you're left with x minus 1 times x plus 1 being less than 4 times x minus 1 by x minus 1, okay, because that is x minus 1 squared. Okay, so let's multiply. So x by x, x squared, x by 1 is x, minus 1 by x is minus x, minus by plus is a minus, once 1 is 1. Okay, I am going to do these two first. So x by x is x squared. When you have 3 things to multiply like this, you tend to do any 2 of them first and then multiply the answer by the third one. Okay, and it doesn't matter which 2 you do. So x by x, x squared, x by minus 1 minus x minus 1 by x is minus x plus 1. Okay, so minus x plus x cancels. So I have x squared minus 1 being less than 4x squared minus 4x minus 4x plus 4. Okay. I'm going to bring everything over to the left. Minus 4x squared plus 4x plus 4x minus 4 is less than 0. Okay, so let's tidy up. I have x squared minus 4x squared, so I have minus 3x squared. I have plus 4x, so that's 8x. And I have minus 1 minus 4 is minus 5 is less than 0. I'm going to change the signs all the way across because I like plus x squared. That changes the direction of the inequality. Okay. And then I am going to solve this either using the minus b formula or factorizing. Okay, so I'm going to do it for factorizing and see does it work, because it's not the most straightforward one for factorizing. So let's give it a bash. Okay, so when I'm factorizing one of these, I get the factors of a by c. Okay, and then I do grouping. So I have the factors of 15, and it's a plus 15. So I have, of course, 15 by 1 minus 15 by minus 1. I need 5, so minus 5 by minus 3, or of course plus 5 by plus 3. So that will give it to me. They are the right ones for the minus 8x in the middle. Okay, so just explain, because there was a number in front of the x squared, I got 15 as my guide number in this case, not just the 5. Okay, you then take the right pairing that gives you the middle one. There's an extra line then in this one. You write them down as grouping. So with grouping, we group 2 together and then the other 2. I don't know if you remember that from junior cert. Okay, so what has happened? Can you see the equation is the exact same? I have 3x squared, I have plus 5, and I've just rewritten minus 8x as minus 3x minus 5x. Okay, so it's the same thing. It's just rewritten to allow me to group them together. Okay, so grouping, I take 2 and 2. Okay, so I'm going to take those 2, and you can see that the 3 in common, and this one is the 5. Okay, so that's why I swapped the order of these 2 when I was writing them down, because I could see it makes more sense to put the 3 with the 3 and to put the 5 with the 5. Okay, so let's factor out of here. I have 3 and an x common, and I have 1x left over minus 1. And then what's common here? It's the 5 and the 5. Okay, and I have x. Okay, and I need the brackets to be the same. Okay, so I need an x minus 1 here. So you can see I've deliberately not put a sign in here yet. So I'm going to put a minus in there, okay, so that I have minus 5x, and then I'll have minus by minus here to give me this plus. Okay, so the brackets are the same. So the last line of grouping is to bring the 2 outer ones together. So I have 3x minus 5, x minus 1 being equal to 0. Okay, of course you could have used the minus b formula for this, no bother at all. X minus 1 is equal to 0, x is equal to 1. Okay, so they are what's called my critical values. So I am deliberately not calling them my answers. Okay, and because they're not my answers, it's an inequality. So the last piece of this is to draw a rough sketch of the coordinate plane and mark in your critical values. Okay, so it's a smiley face because it's a positive x squared. Okay, so let's between 1 and 5 over 3. There's 1, there's 5 over 3, and the equation is, where is 3x squared minus 8x plus 5 greater than 0. Okay, so I've just taken this equation here. Okay, and I've just written it down on the graph on the next page. Okay, so to answer the question, this is your zero line. And when you're above the zero line, you're greater than 0. When you're below the line, you're less than 0. Okay, and that's for any equation. So this down here, let me just highlight it. This area down here would be when we're less than 0. And this area up here would be when we're greater than 0. Okay, so my question to you then is, where is the graph greater than 0? Is it between 1 and 5/3? Or is it outside of 1 and outside of 5/3? And it's actually outside of them. Okay, between 1 and 5/3, the graph goes below 0. Okay, so it's outside of these critical values because they're here that the graph is greater than 0. Okay, so our answers to our inequality, x is less than 1 and x is greater than 5/3. Okay, that is when that graph is greater than 0. Okay, and just explain it now in the context of the question. Okay, so waiting for my screen to catch up to me. I did it with respect to the quadratic, but the quadratic is this inequality just rewritten in a different way. Okay, so I hope that makes sense. We take the question they gave us, we rewrite it. In other words, we simplify it as a quadratic because it's easier to see the quadratic plotted, and we solve it then.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.